This is introduction to calculus. So we're going to start with the derivatives, starting with the power rule. So for the power rule, we begin with any given polynomial in general, y is equal to a x to the power n, like that. Then we have also the constant term where y is equal to c, which can also be expressed as cx to the power 0. So this is how we're going to be expressing any constant term in the given polynomial. So if we're given any polynomial, y is equal to ax to the power n and other terms in that polynomial, the general rule for the derivative is we have to introduce the notation for the derivative. We say dy dx, which is equal to, so when you're differentiating using the power rule, you have to look at the power, this one, and your coefficient. So you just multiply these two, you say n times a, so we get a n, then you drop down this x, so we drop this x like that, then you reduce this power by 1, so n minus 1, you just write it like that, n minus 1, reducing the power by 1. So now we have these few examples where we are going to apply this power rule. So we have example 1. We want to find the derivative of this function, the polynomial. So step number 1, we introduce the notation dy dx like that, which is equal to. So we look at this power 3 and the constant term or the coefficient. So we say 3 times 2, we get 6, then drop this x like that, then we reduce this power by 1. So we say 3 minus 1, we get a 2, like that, minus. So we proceed here. We are looking at this power 2 and the coefficient 4. So we say 2 times 4, we have 8. Then we maintain this x, drop it like that. Reduce this power by 1. So we have 2 minus 1, we get 1. So this is our answer. That's the derivative of this polynomial. Then the other one, we have y is equal to 7x squared minus 4. So for this one, we introduce the notation dy dx, which is equal to, so I'm looking at this power 2. So 2 multiplied by the coefficient 7. So 2 times 7, we get 14. Then you drop down this x like that. And we reduce this by 1. So 2 minus 1, we get 1. Then minus the derivative of any constant is equal to 0. So this is a constant. It doesn't have any letter. There's no x here. So this is a constant term. So when you're differentiating such, you just write 0. Okay, so the final answer here should be dy dx is equal to 14x to the power 1. And x to the power 1 can just be written as x. So this is how we find the derivative. Then we have example 3. So we say dy dx, the notation for differentiation. So I'm looking at this power. So we say 2 times this coefficient. So 2 times 3, we have 6. Then drop this x. Now we reduce this power by 1. 2 minus 1, we get a 1, plus we are looking at this term. So we say the power here is 1. Okay. So we say 1 times 5, we get the 5. Then you maintain the x. Now reduce this power by 1. So 1 minus 1, we get a 0. We can simplify this further by writing 6x to the power 1 plus. Now we have 5. Any number to the power 0 is 1. So this x to the power 0 should give us a 1. So we're going to replace this x to the power 0 with the 1. Then we can simplify this as x to the power 1 plus 5 times 1, we get 5. So this is the answer. Now let us look at the last example. So this is y is equal to 15. Remember the rule. The derivative of a constant term is equal to 0. So this is a constant because it doesn't have x. So we write the notation dy dx for the derivative, which is equal to, so the derivative of 15 is equal to 0. So if you want to know the reason why the derivative of a constant term is equal to 0, we can actually use the same example. So when you have any constant term in your function, let's say y is equal to 15, this term has x, but that x is to the power 0. So if we want to show, we can actually include the x. So this in actuality can be written as 15x to the power 0, like that. Why does it make sense? We know that x to the power 0 is equal to 1. And that 1 times 15 will give us back the 15. So by writing it like this, we are not changing the meaning of the original function. So when we try to differentiate this dy dx, we say is equal to, so the rule for differentiation is the power multiplied by the coefficient. So 0 times 15, we get 0. Then drop the x, so like that. Then we reduce this power by 1. So we say 0 minus 1, 0 minus 1, we get negative 1. So we put negative 1. So the result is 0x to the power negative 1. And remember that there's a silent multiplication here. So this is 0 times this term. So when you multiply anything by 0, the result should be 0. So we have verified that the derivative of this constant term is equal to 0. So we can also apply the same rule here, where we introduce x to the power 0 if we want to see exactly how we obtain 0. But all in all, let us maintain the rule that the derivative of any constant term is equal to 0. So if y is equal to c is a constant term, then dy dx of that constant term c is equal to 0. So this is introduction to calculus using the power rule. Thank you very much for watching. We'll see you in the next video.